Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Inshallah, this is chapter 1, entitled as Oscillatory Motion. Let's begin for chapter 1. If you take a look on the storyline within your textbook, okay, it's talking about grandfather clock, isn't it? So grandfather clock is using the concept of pendulum, whereby the time read out by us as the consumer, based on the time taken for this grandfather clock to make one complete oscillation, for one complete swing. So we can calibrate the grandfather clock, according to the known gravitational acceleration at that particular place, based on the formula of the period for simple pendulum. With that, we are going to determine how much or how big or how what is the amount of the length to be used exactly to produce 1 second. Motion of an object attached to a spring. This is the simplest model where we are going to talk about two models actually. Pendulum, as in grandfather clock just now, and also mass spring system. So as we know before this, this is implies of what? Similar to Hooke's law, right? I believe that you still remember about Hooke's law. So what is happening to the mass spring system here? Let's say we have a block, with mass of m, attached to a spring. This is the equilibrium position of the mass block system at rest. This is the position of it at rest. We are going to displace the block to the right. So the displacement of the block from equilibrium position is to the right to the amount of positive x of displacement. At the instant we are going to release the block, from our hand, there must be a force within the spring. Fs here is the force within the spring. This Fs going to restore the block to its original position. So Fs here, going to restore the position of the block here to the equilibrium position. That is why it has negative sign here. Because the Fs and the x always in opposite direction. So just now we displaced the block from equilibrium position to the right. However, force within the spring going to bring the block to the left. And here is the constant. So actually it begins with this. Right. Then if you want to put it in terms of mathematical statement or formula, then you are going to have a constant. The K is a spring constant, or also known as stiffness of the spring, also known as force constant. Now what will happen? At the moment, the block is reaching the x equivalent to 0, the equilibrium position, x equivalent to 0. Based on this equation, whenever the x is 0, the Fs going to be 0 as well. However, due to the conservation of momentum, because at this instant the block is in motion, it cannot stop all of a sudden. Based on conservation of momentum and inertia, the law of inertia, the block going to proceed to move to the left until it reach the position of negative x at this instant or this side. Whenever it reach negative x, the Fs now going to be to the right, in opposite, displacement to the left, and the Fs going to be to the right. That going to move the block towards the equilibrium position again, right, in opposite to the displacement just now. Whenever it reach x equivalent to 0, again Fs going to be 0 based on this formula. However, due to the law of inertia and conservation of momentum, the block going to proceed to the right, reaching positive x position again. Okay, we consider this motion going to be carried out back and forth until the end of time, because we consider, or we assume, a perfect case whereby there is no friction between the block and the floor, as well as there is no internal friction within the spring itself. Okay, that is how we consider mass spring system as one kind of simple harmonic motion. Okay, why is it simple? Because we consider every single friction does not exist, even air drag also does not exist. We also consider internal friction also does not exist, and then the motion going to move, if we start here from positive x, is going to reach negative x this side, and again back to the positive x, and again back to the negative x, back and forth forever. Any single object that is in motion, it has to obey Newton's second law, right? So what is Newton's second law? Is F equivalent to ma. What kind of F? F net. Okay, F net, or sum of F along x, must be equivalent to the mass of the object times with the acceleration of the object along x-axis as well. Okay, and this force also is the negative kx. Therefore, we will have negative kx equivalent to max, where we can rearrange it, and we have ax equivalent to negative k over mx. So this is a constant. Okay, negative k over m. K is the stiffness of the spring, m is the mass of the block. So the one that going to vary is x. It means that the acceleration of the mass spring system, okay, going to be varied according to the x. So at this position, okay, the value of A is different compared to this position, the middle position, the equilibrium position, or to this side as well. And always the AX is in opposite direction to the X. Means that if the X is to the right, then the A will be to the left, because according to this. Right? Next slide. Analysis model, particle in simple harmonic motion. So what we have in our hand just now, okay, is this one. Okay, AX equivalent to negative K over M times X. Okay, we know that A is actually d square X over dt square. Okay, second level or second derivative of X to the respect of time is actually acceleration. So this one also can be written in terms of this term, which is equivalent to negative K over M times X. And we are going to substitute K over M here is equivalent to omega squared. Right? Why is it must be squared? There is some explanation later on. Okay, so now we are going to take this one as omega squared. So d squared X over dt squared equivalent to negative omega squared X. Right. So what is our X? Alright, what is our X? Our X is actually as a function of time. Okay, as a function of time, where it is in terms of cosine function, a cosine omega t plus phi. So remember, when you have a cosine function, the whole bar here, supposedly the angle. So omega t is actually a theta. This is actually a theta plus phi. Phi also a kind of angle, but it's explained about the initial condition of the object position whenever the time is 0. Is there any displacement or not yet? Okay, what is A? A is maximum displacement from equilibrium position. Again, I repeat, A is maximum displacement from equilibrium position, or simply known as amplitude. Okay, and omega t is actually theta. Why is it so? If you still remember our previous lesson in physics 1, omega is actually delta theta over delta t. Right, so if you have omega t, this is actually delta theta, or simply as theta. Right, so phi here is phase angle, is actually phase angle, a kind of angle as well, giving us information about condition of position of the object, where is the x of the object whenever the t is 0. Right, so before we further discuss on this, okay, let's take a look on dx over dt firstly. So if we want to differentiate, why are we concerning about this? Okay, because we want to fulfill this equation. Dx over dt is equivalent to, take every single here, because this is the x function, to be written here, and a is a constant, so take it out. So what are we going to differentiate is actually cosine function, omega t plus phi to the respect of time. Which one has the t? The omega, right? Right. So means that we want to differentiate this part. Okay, this part. But then this part is a function of cosine. Meaning that before we manage to differentiate this one, you have to differentiate this part firstly. So, okay, differentiating cosine function will give you negative sin. We're going to do dx over dt. What is your x? Your x is a cos omega t plus phi. The whole part of this is your x to dt to the respect of time. So you're going to take out the a, d cos omega t plus phi, the whole part of this over dt. So differentiating cos will give you negative sin omega t plus phi. Just now you are differentiating the cos function, the cosine function, giving you negative sin theta. What is your theta? Omega t plus phi. And then after that, you're going to differentiate the one that having t, isn't it? Because your aim right now, you want to differentiate to the respect of time. So you're going to differentiate which one having the t, the omega. So how is it going to be differentiating? Omega t give you, okay, omega a, negative sin omega t plus phi. Why we do nothing to the phi? It has no t. It's just a constant. Okay, so rearrange of this equation, it will give you negative omega a sin omega t plus phi, which is similar to this. If you want to do second level or derivative of your x to the respect of time again, because our aim here is to have the a, formation of the a. So again, you are going to differentiate this function. This is your dx over dt. What is dx over dt? This is velocity. Okay, so if you want to have a, you have to do d square x over dt, right? it means that you're going to do the derivative of this function. Okay, to the respect of t again, right? So when you differentiate sin, okay, it will give you positive cos, right? Then differentiate within the whole bar of the theta here, the one that having t is this one. So it will left you with omega. So just now you have negative omega A as a constant outside. You're going to differentiate sine omega t plus phi to the respect of t. So you're going to have the product of differentiation process of this. You're going to have cos omega t plus phi, then followed by differentiation of this part, you will have omega only. That omega going to be multiple in front here. That is why you're going to have negative omega square A cos omega t plus phi. This is actually differentiation process for trigonometry. Okay, then analysis model still particle in simple harmonic motion. So talking about x as a function of t means that x is varied or changing according to the t. Okay, based on this equation, A cos omega t plus phi can be visualized by this diagram. So if you see here, this is from this point to this point is a complete cos function, shape of cos function. Alright, it has phi. Where is the phi? The phi is here. The phi is talking about, we are talking about the condition whenever your t is 0. Okay, the object already certain angle, right? Which is already being displaced at certain angle, not starting at maximum amplitude or maximum displacement, also not starting at the 0, okay, or equilibrium position. So it already has an initial condition. Alright, and then another information about period. Period is time taken to complete one vibration or complete sinusoidal wave function. So this is your period, time taken. Okay, and as we know just now, omega, angular frequency for mass spring system, is equivalent to square root k over m, because just now we have omega squared equivalent to k over m. Alright, and then for figure B, okay, what is given here, whenever the phi is 0, okay, the object completely at amplitude, maximum displacement. So for this one, the function of this one is x as a function of time, where it is actually cosine omega t, because the phi is 0. This is a completely a cos function, okay, without addition of phase angle or initial condition. So let's proceed with further investigation on the mathematical description of a simple harmonic motion. Right, so the period t for the motion, okay, is the time interval, as we know. Okay, this is actually the time interval needed or taken, okay, for the particle to go through one full cycle of its motion. Okay, so let's consider this figure. This is figure 15.2a in your textbook, page 389. Okay, so if we consider this figure, okay, that is the t is the value of x and v, okay, for the particle at t equals to the value of x and v at t equivalent to t plus t, capital T right now, because it's already complete one circle. Initially it has T time. After one complete circle, the time taken, the total time taken already T plus T. Okay, so whenever it's already moved one complete cycle, initially it has T. Okay, then after one complete cycle, this is the first step. Second, one complete cycle, the T right now, okay, already T plus capital T, because one complete cycle, the time taken is capital T or period. Alright, so okay, because the phase increases for one complete cycle, how big the phase or the angle covered by the object in motion? For one complete cycle, okay, covering or within capital T period, the displacement, angular displacement already 2 pi. Okay, so within this, okay, it's already covered 2 pi of angular displacement. Therefore, what does that mean by this? It must be theta final minus theta initial equivalent to 2 pi. What is your theta final? Your theta final is omega T, the whole bar here, plus omega capital T plus phi. This is your theta final. Your theta initial is omega T plus phi. Right, must equals to 2 pi. Right, so if you have it here, the omega T will be cancelled with this one, and the phi also going to be cancelled with this one. So you only left with omega capital T equivalent to 2 pi. Right, so from here we may rearrange our interests or the topics or the item on our left side, which is the capital T, the period of a motion, is equivalent to 2 pi over omega. And we know that, okay, reciprocal of T is actually frequency, linear frequency. Omega is angular frequency. So F is equivalent to reciprocal of T, equivalent to omega over 2 pi. Therefore, we can have another relationship, omega equivalent to 2 pi F, equivalent to 2 pi over capital T. Then, if you want to refer back to the mass spring system, your omega is actually square root of K over M. So, if you substitute within this equation, okay, your omega here for mass spring system, okay, it's equivalent to 2 pi square root M over K, because it's over, right? So it's going to be inverted. Then this is for period, and here will be for frequency. Right. Okay, so now let's take a look on the velocity. Velocity is defined as the rate of change of position to the respect of time. So what is our position? Our position, if you recall, our x actually is A cos omega T plus phi. This is our x. Okay. To have V is actually dx over dt. So differentiate the cosine function, okay, will give you negative sine function, right? And then after that, we're going to differentiate inside here the omega t, because the differentiation is to the respect of time. So differentiating omega t to the t will give you omega only. So omega will be bring outside. Okay, that is why the final equation is negative omega a sine omega t plus phi. Consider the whole bar here as a kind of one single angle theta. And here is the acceleration. Acceleration is defined as d squared x over dt squared, okay, which equivalent to, means that you are going to do A is actually a differentiation, okay, okay, d of your v, in other meaning, dt. What does that mean? You're going to differentiate the function of negative omega a sine omega t plus phi to the respect of time. So differentiating sine function will give you positive cos. Okay, then you are going to have a cos. Okay, negative here remain negative. Okay, omega. Okay, a cos omega t plus phi, and then after that this one is a constant, so it remains here. Okay, the one that will differentiate this whole bulk. Differentiation of sine function will give you positive cos. Once you already differentiate the trigonometry function, then you're going to differentiate the things that with the t, which is your omega, right? Then you're going to have another omega in front. Okay, simplify or make it even better. So negative omega squared a cos omega t plus phi. This is actually your A. Right. And then to have a velocity maximum, okay, a velocity maximum is equivalent to omega A. How come? How come? Let me show you. How come V maximum, okay, is equivalent to omega A? Where is our V equation? Here. This is your V equation, right? Maximum value for sine function is what? 1, right? Maximum value for sine function, for cos function, 1. Okay, the one that with more than 1 is tangent. Okay, sine and cos maximum value for them is 1. Therefore, if we're talking about V maximum must be negative omega A. The whole bar of this sine omega t plus phi here. The whole bar of this one must equivalent to 1. Okay, because we are talking about V max. That is why the formula becomes, okay, negative omega A. But if you are talking about speed only, magnitude of V max, then you don't have to consider the negative sign. You will get omega A. Right? But if the question asking for velocity maximum, don't forget about the negative sign. It has meaning. Okay, direction of the motion. Okay, goes the same for the A max. Okay, when you talk about A maximum, you are talking about negative omega A cos omega t plus phi. So maximum value for this function should be 1. Therefore, you're going to have omega square A only. If you're talking about magnitude of A max, then you're going to have, which is omega square A only. Right. Okay, how about this graph? Okay, this is actually from your textbook, figure 15.5, page 391. Okay, this is graphical representation of simple harmonic motion. Okay, for figure A is position versus time, and then figure B, velocity versus time, and then figure C is actually acceleration versus time. So this is the one that we described just now. X is equivalent to A cos omega t plus phi. And for this one, V equivalent to negative omega A sine omega t plus phi. And for A here is negative omega squared A cos omega t plus phi. Let's double check. Okay. So according to this graph, where is the x maximum? X maximum is here, right? It's here. It's positive. This is negative. Okay. So the amplitude is the x maximum. If you want to have x maximum, okay, is going to be the whole bulk of this function going to be maximum in value, which is equivalent to 1. Therefore, x maximum is equivalent to A. Proof. Okay, for V maximum, just now I already show which equivalent to negative omega E. Right. So, for acceleration maximum is equivalent to negative omega squared A. And you may replace the omega with square root k over m for mass spring system. Okay. Now, okay, as we know, this is general equation for position versus time. X as a function of t, A cos omega t plus phi. Sometimes we write it properly. You may also drop this, understood that x is varied or changing according to the t. And from here, we already discussed that the omega equivalent to square root k over m. So now, let's take a look on this system. You have a mass spring system. Okay, at x equivalent to 0, you already displaced the object at position A to the right. Okay, at this initial, at this position, the counted time considered 0. We haven't count anything yet. We haven't begin the system. Right. Initially, okay, the block already has position of amplitude positive. Okay, and initially, the block is not in motion yet. Okay, so how to translate this situation into equation? You may see here, okay, at t equivalent to 0, omega t going to be 0. Consequent of that, x, whenever the t is 0, is only equivalent to A cos phi. Okay, if you don't have A cos phi, is equivalent to A only. Okay, and then for velocity at t equivalent to 0 is equivalent to negative omega A sine phi equivalent to 0. X equivalent to A cos omega t. Okay. So now this is the graph of the things that we explained just now. For this kind of situation, okay, for this kind of situation, at t equivalent to 0, the object already has position at positive A to the right, and its initial velocity is 0. So the sinusoidal wave function for it is this one, which is x equivalent to completely A cos omega t. And then for velocity Okay, then your function will be like this, and here is negative omega squared a cos omega t. Basically, it has no phase angle for this case. Okay, whenever t equivalent to 0, the x is at a, there is no phase angle or phi. So the equation going to be simplified like this. Okay, let's consider another possibility for the motion of the mass spring system. Let's say, okay, the system is in motion, okay, oscillating, and at this instant the object is passing through the unstretched position, or we call it equilibrium position, x equivalent to 0, while in motion to the right. V initial is to the right. At this moment, at this instant, we consider t equivalent to 0, x initial equivalent to 0, and v is equivalent to v initial of the object or block. Okay, and the three condition, okay, the condition that we have before, x as a function of t whenever the t is 0 must equivalent to 0, and v as a function of t which is at 0 must equivalent to v initial of the motion. Right, based on that, right, this only can be satisfied whenever, okay, take a look on this, okay, whenever our phi is equivalent to negative pi over 2, then this equation is satisfied. Phi, it could be positive pi over 2 or negative pi over 2. Right? Why is it positive, negative? It's displayed on which direction of our block is in motion. Okay. The second condition, if let's say we choose the phi of positive, and if you see here, between x and v, okay, it's always in opposite direction. Remember, okay, for simple harmonic motion, the direction of displacement and the direction of the velocity always in opposite direction. That is why we have negative sign here. So if let's say you have phi equivalent to positive negative pi over 2, therefore your A will be in opposite direction, the motion, which is negative, positive, V initial over omega. Okay, why is it so? Because right, the initial velocity is positive and the amplitude must be positive. So to fulfill this condition, because the initial velocity is positive and the amplitude, how we know the initial velocity is positive? Because it's to the right, right? And the phi must be in opposite direction. If the V to be positive, okay, the V to be positive from this equation, alright, so the V is positive, therefore your phi gonna be negative pi over 2, right? Then it will satisfy the condition given in this situation. Alright, so based on that, then we are going to substitute, okay, the A with the V over omega here, and also, okay, the phi here. Okay, then the equation going to be like this, look like this. Okay, because the A is according to this, substitute the A here. This is your A, because the initial condition or equation is A cos omega t plus phi. Remember this. So based on this this condition, we know that our V initial is positive. If the V is positive, then the phi will be negative, opposite. See the sign, opposite. So that is how we know the phi is negative pi over 2. Why is it pi over 2? Because it's one fourth of the quarter of the complete oscillation. X equivalent to A sin omega t, right? Okay, which is also, this one is V equivalent to omega A cos omega t, and here we have A equivalent to negative omega squared A sin omega t. This is actually is the same thing to the one that we state just now, X equivalent to, okay, if we refer to A cos omega t plus phi, our previous equation, then you're going to have A cos omega t minus pi over 2. Right, to make it cos, okay, to make it cos function in terms of graphical, this is the pattern of cos, right? So it is delayed by this phi. This is your phi, which is pi over 2. Delayed behind, that is why it's negative. Right. Then for V, okay, we have omega A cos omega t. This is also equivalent to the one that we have before this, negative omega A sine omega t minus pi over 2. Right? So what does it mean by this? This one, right? Negative of sin function. Okay, and also delayed by pi over 2 of phi. Right? And then for A equivalent to negative omega squared A cos omega t minus pi over 2. Right. Why is it negative cos? Here to here, it's negative cos. This one is positive cos. This is negative cos. Right, and also delayed by phi pi over 2, that is why it's minus. Okay, so this is in terms of meaning. In terms of mathematics, okay, actually sin function and cos function can be converted to each one. It just that for cos, okay, you must add up negative pi over 2, because to have a shape of the cos, okay, it's originally sin function. So sin, okay, moving first, while cos is behind or left with this phase angle. That is mathematics. In terms of physics, we have this kind of meaning according to the motion of the object. Alright. Okay, so now analysis model, particle in simple harmonic motion, we've done with the math. Now we want to take a look on the physical things, character or information from the sinusoidal or graphical illustration of the motion for our SHM or simple harmonic motion. Okay, what we have here in our hand right now is mass spring system. Okay, so we know that x as a function of t is equivalent to a cos omega t plus phi. And recall back that t is equivalent to 2 pi over omega. What is omega for mass spring system is equivalent to omega itself. Okay, omega itself is equivalent to square root k over m. Right, so if you over omega, that is why it's inverted. Alright, what is period? Period is the time taken to complete one motion, one complete motion or oscillation or vibration. So one complete motion must be one complete cos or one complete sin function. Alright, what is A? A is maximum displacement of your object from the equilibrium position. Where is your equilibrium position? Here, where x equivalent to 0 is your equilibrium position. So what does that mean by this? Positive is to the right. What does that mean by this? Negative is to the left. Okay, still is amplitude, but then in left side. Okay, the direction. Right. So take a look on the example 15.1. Okay, a block spring system, 200 gram block connected to a light spring for which the force constant is 5, okay, Newton per meter, is free to oscillate on a frictionless horizontal surface. The block is displaced 5 cm from equilibrium, so this will be our A. This is our A. And then here and here another information. This is our mass converted into kilogram. And here is our K, stiffness of the spring or force constant. Okay. So from this information, what we have here, okay, from equilibrium and release from rest and its figure. So means that, okay, means that at T equivalent 0, the block already has initial position at A, right? So, okay, find the period of this motion. So we are going to use omega equivalent to square root K over M and T equivalent to 2 pi over omega. Then you will get your T, the period. From here you get your omega firstly. Okay, so it's up to you whether you want to calculate part by part or you directly substitute here. It's up to you. Determine the maximum speed of the block. Okay, as we know, Vmax is equivalent to, originally Vmax is equivalent to, okay, but if you're talking about speed of the block, means that V maximum, first thing first, maximum means the whole function here is 1. And if you're talking about speed, then you are talking about magnitude only. That is why you have omega A only. Right. Then see what is the maximum acceleration of the block. A max, supposedly initially A max equivalent to negative, okay, omega square A cos omega T. So for this case, if talking about, I believe that it is asking for maximum magnitude of the acceleration. So that is why this function like this. Right. Okay, express the position, velocity and acceleration as a function of time in SI unit. So the whole part of this only correct, okay, when your phi is 0. So because why we know the phi is 0? At the instant T is 0, the block already has position at A, positive A. Right? If you starting from here up to this is a complete cos function, which is x equivalent to A cos omega T. There is no lagging or leading behind. There is no part that okay, where the shape is not enough, isn't it? Similar to this one just now. See, for this one, it has a shape of, we want to have a cos function or shape, but then it has a part where it is started behind. That is why you have this compared to this one, you have a complete shape. Of course, you have no leading lagging, right? So that is why there is no phi in terms of simple meaning, okay, to know that the phi is 0. So when you have this, okay, substitute the whole bar of the information already calculated in previous parts, okay, where A is this value and your omega is this value. Just bear in mind, if let's say for the question, let's say, or another part of the question, let's say, asking for the value of your x when t is equivalent to, let's say, 0.1 second. When you plug in value of t here and you want to calculate it, don't forget that this unit is in radian, because omega t is radian per second times time, so you left with radian. So the unit of this, the whole bar here, is in radian. Therefore, if you want to press your calculator, make sure you already change before you press cos something here. You already put your calculator in radian mode. Otherwise, you have to convert this into degree. Okay, so the easiest way is to make your mode, the mode of your calculator, into radian mode. Okay, be careful with that. So goes the same for the V. Okay, you just substitute the rest of the value and A as well. Right. So next one, what if the block were released from the same initial position but with an initial speed of this? Which part of the solution change, and what are the new answer for those that do change? Okay, so now the first condition, we know that x when t equivalent to 0 must be equivalent to x initial, right? And v at t equivalent to 0 must be the v initial. Okay, so if you refer to this, the solution is in this part is actually the ratio between v initial to the x initial. Because of sine ratio to cos phi, you're going to have tangent phi. What is the purpose? To simplify this part. Okay, so if you have only tangent phi is equivalent to negative v initial over omega times x initial. So you may substitute everything, you will get the value, because you already have the information given for this one, and also this one. Alright, from here you may determine the phi, which is 0.121 pi. And to have the A, okay, with this, okay, condition, right, because of this, right? Okay, so make use of this equation, determine the A, substitute the phi that you calculated here, you will get your A, right? Then, okay, from here, you're going to determine V max omega A. Use your A that you figure out from previous part. And A max omega square A. Both of these talking about speed and magnitude only. And then if you want to put it in terms of mathematical expression, now you may redo again the part for this, substituting the value of A, the value of omega, and then your phi. Okay, the value of your omega A, omega t, and the phi goes the same to this again. That is how to solve this part. And now, example 15.2. Okay, consider again the block spin system in the previous example. Okay, the same. But now, whose position, velocity, and acceleration are given in part D of the problem. So, we're going to take the information from part D of the 15.1 example. Find a general expression for all times at which the block is located at x equivalent to plus minus half of the A. It's not reaching the A, it's halfway to the A. Alright, we have position of the x. Okay, A is equivalent to the half of the A. This is a condition given to us. From this, you can cancel out the A. Then you're going to solve for t. Then before you be able to solve for the t, you need to know that, okay, this information, okay, up cos of half is actually equivalent to 60 degree. 60 degree, it means that 180 divided by 3, it means that it's equivalent to pi over 3. Okay, so that is why the solution, if you refer here, is pi over 3 plus 2 pi times n. N is the order, right? Because the motion is repeated, right? So because it's moved to the back and to the forth, back and forth forever. Okay, so we have a number of repetition for the cycle. So how about this one? This one is for one complete cycle or vibration or motion. So this is the solution for this part. And then here is the part of the repetition. So 2 pi n, this is the first time it's a time, and then plus the second time. The second time, whenever it's complete one cycle, then it reach the same position to this again. That is why we plus 2 pi n. N is the order, and the order must be 0, 1, 2, 3 and so on, must be integer, right? This is for the first okay, for the first cycle. Okay, and then this is of second time, for second time that the position of the block reach, okay, whenever that x equivalent to half of A, right? For this one, why is it 5 over 3 here? Why is it 5 over 3 here? It's because it's already passed through the initial condition here, pi over 3 plus 2 pi. Okay, it means that how to get okay, 5 pi over 3 here, it's actually pi over 3 plus 2 pi. This gives you 5 pi over 3. Okay, it means this is for second time. For the second time, the object going to be at this position, x equivalent to half of the A. And again, for another repetition, it must plus 2 pi n order. And the n is 0, 1, 2 and so on, integer number. Okay, if you want to simplify this equation, you may put it like this. Goes the same to this, you may put it like this. Okay, it's just mathematical expression. The most important, you understand what does that mean. So from here, then another step, okay, you are going to determine the t. Okay, 1 over omega, substitute the omega from part D of example 15.1, okay, which is 5 per second. Then you will going to have, okay, solution for the cos phi, right, cos phi to this, substitute to this, and then you will get this answer. Okay, for the first cycle or first time, its place is reach x equivalent to half A, and then here for the second time it reach the position of x equivalent to half of the A.